Hello folks, this is Tom from anti-proton.com, and I'm here today to talk to you about logic, what is true, what isn't true, that sort of thing. The reason you want to know this is because you want to separate what's true from what's false. The internet's full of things that are false. You constantly get claims from people that say this, that, and the other, and it's actually reasonably difficult to prove something true, but it's not too difficult to prove something false. And in fact, we could get into where science would actually say you can't prove anything really true, but whatever. We'll get into that in a minute. Itchy. It's really hot in here, too. It's driving me nuts. Basically, I have this black curtain behind me, and the sun's hitting it. Take a guess what black curtains and suns do. That's right, they barbecue you. So let's get into a little bit of logic and why things are or are not true, and then a list of some really basic fallacies that you're going to bump into on places like YouTube so that you can know the difference. And by the way, I should point out I am not a philosopher, but in college I did take logic classes. I don't think you should be allowed to graduate from college, even with an associate's degree, without taking logical classes, certainly not from an undergraduate. And they should be taught again in graduate level as well, as far as I'm concerned. I don't think there should be any level. In fact, you know what, heck with that, they should teach them in high school too, because people need to understand logic. We don't have very many critical thinking skills anymore as a society. Have you ever noticed that? People just make all kinds of random claims and whatever, and they don't seem to know any different. So I think this, of course, is a societal issue, but moving all of that aside for a moment, that's just my suppositions. First off, let's get into when you do and do not need logic. Okay, if I'm producing a video where I'm talking about my phone or something like that, or I'm saying, I like this bottle of wine, it's great, I may or may not need logic. When you and I are bumping into each other in the street and I say, well, I don't think that the mall over there is as good as the mall over there, I may not need formal logic for that, because we're having kind of a just you and I sort of conversation. We're speaking in colloquial terms. We're not really getting into science or anything like that. Until I'm starting to make things like formal claims or formal discussion, those sorts of things are not really needed. It's nice to know them, to know you're not completely just talking smack, so to speak, but it's not something to hold people to it. And in fact, it is almost a fallacy in of itself to take a person, get them into a conversation. Hey, what's your favorite fast food place? Oh, you like that place? Why do you like it? Oh, you think the burgers taste the best? You think the burgers are better there than here? Show me statistical evidence proving that the burgers are better. If you lure somebody into a just a happy-go-lucky water cooler conversation and then try to dump a bunch of hardcore logic on them like that, that in itself is a logical fallacy. So just keep that in mind. There is a time and place for logical fallacies. Time and place for logic, and a time and place for not illogic, but this kind of everyday sort of, logic. And so you shouldn't mix the two up too badly. And I've gotten into debates with people before where we were just kind of back and forth debating. We're not really getting into like a really formal debate, and then they try to force that upon you. It becomes kind of a pain. Okay, so we know that we don't need logic all of the time. And when I say, I'm defining logic, by the way, as being structured logic. I am not defining logic as in basic logic. Obviously, we need basic logic or we won't even know how to speak. But you get that idea probably. Okay. Second thing I want to get into is definitions of things. Have you ever heard people say, that's just a theory? They don't even know it's true. Things like that before. Well, how can science say that evolution is true when it's just a theory? I mean, it's a theory. It's not even true. It's not even a fact. People say stuff like that, and in everyday speech, what I just said actually makes sense. But in science, it does not make sense. And I want to make this very clear because this is such massively misunderstood stuff. What is the difference between facts and theories and so on? Well, let me start. Everything that exists, let's take this dice. No, forget the dice. Let's take this garnet. Okay, big giant garnet. So this garnet has mass and weight and so on. If I drop it, it will fall, right? Okay, so that was a phenomenon. We witnessed a phenomenon. I let go of this and it fell. It accelerated towards my hand. That is a phenomenon. So is burping. So is wind. So all kinds of things. Salt crystals forming. It's all phenomenon. Phenomenon does not tell you anything about what it is. It could even be a false phenomenon, like you feel cold air blowing across you and you think, oh, cold must be a phenomenon. Cold is, of course, not a phenomenon. It's the absence of heat, which is itself a phenomenon. So phenomenon are things that occur in our everyday lives. If we watch a phenomenon and observe it for a while, We can just go, like, let's say we have a drain that water drips out of. We watch the dripping occur. That's a phenomenon, right? And we might say it is a fact that right now water is dripping out of this pipe. And I might take my hand and put it into a pot of boiling water and burn myself. And I might say the boiling water is a phenomenon. My burning of hand is a phenomenon, and it is a fact that my hand just got burned when I put it in the water. I'm not saying that the water did it. I may suspect it, but I'm not saying it did it. I'm just saying that these are phenomena that I see. Now, science exists to try to explain these phenomena, and even better, the most important thing of all that everybody seems to miss, predict the future of how these phenomena will unfold. I don't mean like predict the future like a crystal ball or anything, but I mean predict that if I stick my hand in the water, it will be burned. Okay, so we have facts and phenomena, right? Got it? Facts are kind of like observed phenomena that are somewhat consistent. Well, we start to suppose things. Well, could it be that magical force pulls the rock down, air is blowing, magnetic fields? So we start supposing. These are suppositions. Well, I suppose it could be a magnetic field pulling it down, or a gust of air blowing straight down. These are suppositions. It's hard to shoot down a supposition because the supposition is necessarily not based on anything other than observing phenomenon and facts, right? It's not usually based on any particularly heavy amount of evidence. You see something happening, you kind of spitball an idea. It's a supposition, okay? So you suppose this, you suppose that. After a while, you start to come up with a realization that there's probably some force that's pulling this rock down. You don't know what that force is. And over time, you'll develop a law. The law of objects falling. We'll call it that. Okay, we call it the law of gravity, but the law of objects falling. A law is basically a set of things that have been observed, phenomena that have been observed that we know occur a certain way. Laws do not describe how they occur. There's the law of gravity. Newton's laws. Newton's laws do not explain why the things happen, but they explain what always seems to happen. And laws, of course, stay true until they're proven false, until one day I drop this and it goes up, and then we have to sit back and think, wait a second, is the law wrong, or did something else just intercede? Gravity is a law, okay? You could say the law of watching the sun apparently rise. And of course, the sun doesn't rise, we turn. But if this were ancient times and we didn't know that, we would see the sun go up and then go back down, and we would call that a law of the motion of the sun, I guess, heliomotion or something. So basically, that's what a law is. A law does not supersede a theory. Now, sometimes you'll hear people say that a really, really, really strong theory becomes a law. The reason that sometimes gets screwed up is because take the law of gravity. Over time, we know what the law of gravity is. We know things fall, and there's a theory of gravity that describes how that happens, and over time, the two kind of get mingled. People don't seem to split them apart, and that's how come they get those screwed up. So anyway, hold on. All right, so we have the phenomenon that this falls. We have the fact that every time I drop something, it falls. Those facts are well observed and well documented, and they become a fact. The fact that objects fall, we'll call it the law. It's not the fact, the law of falling, the law of objects falling. We develop suppositions trying to guess it, and over time we rule out a lot of the suppositions. We get down to a hypothesis. There is an unknown, unseeable, otherwise feelable force that exists that pulls objects down, right? We'll call it gravity, just throw it out a name. And we'll call that a hypothesis, the hypothesis of gravity. A hypothesis must be testable. There has to be some way that we can test that it's true. Like, I can't hypothesize that an invisible dragon exists here that grabs the object and pushes it down, but there's no way the dragon can be interacted with in the entire universe. No way other than pushing the object down. That's a useless phenomenon, because, or not phenomenon, useless hypothesis, because you can't prove it. You can't disprove it either. And of course, in science, you don't prove anything true. You prove it close to true, somewhere in between 0 and 1. Percentage. You can say, well, it's more likely than not, so to speak, is a better way to put it. You don't prove things false. You don't prove things true. You prove things very likely and very unlikely, and we're somewhere in between. The dragon pushing it down, I can't come up with a metric of how true that might be, because there's no way to test it. It's unfalsifiable. So claims that are made that are unfalsifiable are not necessarily untrue. There could be a dragon here, but it's useless to go on about them because you can't prove them. You can never test them. So what's the point? Okay, they might as well not exist. So now we've got this hypothesis. Over time, a hypothesis or several hypotheses that are proven over and over and over to be correct. I mean, just clockwork. Every single time we discovered that the object falls at a particular rate and all this stuff are bundled up together. And sometimes a single hypothesis if it's really, really good too, but usually several of them. They're put together and they become a theory. Theory is the highest form you take in science. The theory of gravity. Theories are well supported by facts, and theories are well supported by facts. Okay, a theory explains something. It has explanatory powers, right? Like that. It has predictive powers. It says, if I drop this and it falls from a particular altitude, then the amount of time it will take it to hit here is such and such based on math and whatever. These are predictive powers that theories have. And a theory predicts the way a system unfolds given time or other variables and changes in those variables. Theories can be proven wrong. Do you remember a year ago or so, somebody tried to undermine the speed of light? Okay, and they almost did. They thought they had credible proof. And I mean, these guys were high up there in skill, and their stuff should have been true. And it turned out not to be. But science took that very seriously. And people oftentimes accuse science of not. And one of the reasons science tends to dismiss stuff is because scientists get hit with so much complete garbage by people 24/7 that they probably just ditch most of it because they're just sick to death of it. I mean, I trust me, you wouldn't believe some of the weird emails I get. But anyway, and I'm not even a full scientist, so God only knows what they have to deal with. Now, so that's the difference between a theory and a fact and law. And so, like evolution, for example, is a theory. It is not proven true. It is not proven false. But for the last 100 years, the amount of evidence to suggest that it is true is tremendous and piles up every single day. I just had another article about evolution determined with some kind of little mite things in a lab. And in fact, more is known about evolution, and there's more evidence for evolution than there is for example, the theory of gravity. Evolution is much more well supported. And yet both of those are, of course, very well supported because they both have good predictive powers. Now, let's move off into the next thing. Let's move off into what's true and what's not true. Simple things are usually pretty true. We have syllogisms, modus ponens, modus tollens, things like this. Okay, let's get into what these mean. Okay. A syllogism is a way of describing something in a true sort of form as long as the assertions are true. That's a crappy definition. Let me give you a better one. Okay. Major premise. Minor premise. Conclusion. Let me give you an analogy. Let me give you an example. I have one written right here. Fish live in water. That assertion is probably true, right? If you want to get all crazy about mud skippers and stuff, just ruin my parade. Fish live in water. Trout are fish, right? A trout is a fish. Okay, it's a little kind of tasty fish. You put some basil on it. Oh, God, it's so good. So, fish live in water. Trout is a fish. Therefore, trout live in water. Did you see it? It was that freaking simple. True. Now, it's possible we could find out that some of my assertions are wrong, but the benefit of understanding things like what is true and what isn't true and what are fallacies and what are not is that you can dismiss some right off the bat. You can dismiss the goofy ones because you can figure out that they're goofy and wrong. Like, for example, here's the modus ponens ones. A implies B. A, therefore B. Okay, let's see. When water boils, the water is hot. The water's boiling, therefore the water is hot. See, it's a simple truth. And you could go the other way, and you could say, when water boils, water is hot. Water is not hot, therefore water is not boiling. Okay? The first one was modus ponens, the second was modus tollens. All right, those are Latin names for them. But you'll know somebody's tricking you if they say something like this. What would be a good one? The water is not boiling, so they're denying the first part, therefore the water is not hot. Well, that seems to make sense, right? I mean, if A, then B, not A, therefore not B, right? It kind of makes sense until you wait a minute, you think about it. The water doesn't go from standard, regular temperature to boiling instantaneously. It has to go up. So water could be hot and not yet boiling. Okay. If I saw one on the internet a little while ago, if a dog detects an intruder, it barks. The dog detected an intruder, it barked. But the fallacy would be the dog. Let's see. The dog did not detect the intruder. Oh crap! I just screwed myself up. I don't like that one. That one's stupid. I gotta think about it for a second. But anyway, basically what you're looking for are things that positively affirm things, facts that are supported positively and not negatively. You don't try to disprove the stuff. You try to prove your arguments. And that's a big one. See, I just threw myself into a logical loophole there. The biggest important thing you can do is try to prove your argument and not disprove somebody else's argument. That's kind of what those two that I just mentioned get into. Disproving people's arguments is stupid. Don't do it. It's dumb. Bad, 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 bad. Okay, because then you screw yourself up like I just did a minute ago. See, I can't even do that right. It doesn't even flow through my brain right. It's logically invalid. All right. Now, let's get into some logical fallacies. This is the last part, logical fallacies and how one seeks to prove something. So you make a claim. If you are making a non-trivial claim that exceeds or goes against what is standardly known, then you have a burden of proof. Now, what does that mean? A non-trivial claim. If I were to claim something like the sky was blue, well, the sky could be blue. That's pretty damn normal. All right, that's sort of a trivial claim to make during the middle of a day, right? Now, if you're in the middle of a hurricane and you say it, that may not be a trivial claim. It's very hard to determine what is or is not trivial because it really depends on the context of the situation. For example, you might say, it's negative 200 degrees Fahrenheit outside. That may not be a trivial claim where I live. Now, if we were both on the moon and we were astronauts, then it's a trivial claim because, it could easily be negative 200 degrees outside. So it depends a lot on where you are. And the second part is it has to exceed the norm to some degree. For example, if I say, there's air, besides being a trivial claim, we all know there's air. There's no dispute about that. It's not logically invalid to make the argument. It's just pointless. Whereas if I were to say, I believe I'm breathing in mostly helium. Now, that is not supported and known by science to be the case. That's not. There's no general consensus agreeing that that's the case, which doesn't invalidate it. It may be completely true. You would talk like this if you were breathing in helium, but you have to prove it at that point. So you got the idea. Some people make claims. You want to look for non-trivial, trivial, and you want to look for stuff that exceeds the norm. If somebody says, like for example, if I say the world is round, and you're angry and you say no, it's flat. I know I made the claim the world's round, but I don't need to support that because that's the generally held belief. Just because it's generally held doesn't make it right. The world could be flat. It's not flat, but it could be flat, right? And I could be wrong, but I don't need to support that, even though I made the claim, because that's a generally held notion. Otherwise, you'd force every single person who says anything ever to support everything they ever say. It would get obnoxious. All right. So even though the other person with the flat. The person who says it's flat doesn't have to support their claim because they didn't make the claim. But if they turn right around and say, you're wrong, it is flat. Now they've made a claim. And theirs is non-trivial and not supported by a popular belief or scientific belief, that is. And so they need to support what they say. Okay. So that's a burden of proof. I'm going to do one last thing to describe the 10 most common fallacies that you will bump into in YouTube. If you never research anything else, at least know these because you'll bump into them all of the time. And these allow you to figure out what is false. Now, when I say what is false, if you determine an argument to be false, it does not mean the argument itself is actually not true. It means the form of the argument is untrue. What they're trying to argue may completely be true, but they're just doing it in the most dumb, idiotic way as to basically invalidate themselves. So, sorry, you shouldn't assume just because their argument is wrong that they're wrong. But there should be a massive prejudice placed on whether they're right as a result of it. But you should always independently confirm yourself. Okay, list of fallacies. Here we go. Number 1 on the list, ad hominem, depending on how you want to pronounce it, to the men is what it means. And basically, these are arguments against you. Now, for example, what would be a good one? there are times that it's not an ad hominem attack. For example, if I were to say ad hominem, if I were to say, I don't like people from this particular location because they're mean and they say bad things all the time, blah, blah, blah. That's not actually an ad hominem attack. I'm talking badly about these people over here, but that's part of my actual argument. Now, you might say, wait, what do you mean part of your argument? Well, that was part of my argument. Let me explain when it is an ad hominem attack. Maybe that'll help you a little better. Okay. So, you say it's not true. That's because they paid you to say it's not true. Ad hominem attack. What I'm trying to do is undermine you by making you look like you're secretly working for bad people, unless you are. But then I would have to offer absolute proof right on the spot, or else it's an ad hominem attack. If it actually is true, for example, if you say, well, you're not right because you're currently drunk, so how could you possibly form a correct, you've been drinking, how could you possibly be correct? Your mind's influenced by alcohol. If I said that to you in the middle of a debate with a bunch of people, that's an ad hominem attack unless I can prove it's true. If I can prove it's true, I'll be, look, here we go. Put a breathalyzer in you. Oh, look, you are drunk. Now, that's not an ad hominem attack. This is perfectly valid, okay? So an ad hominem attack is when I try to attack you, not your argument. That's an ad hominem attack. Just the fact of saying bad stuff or being verbally abusive or whatever is not actually an ad hominem attack. It's poor form. It's terrible, but it's not actually an ad hominem attack. Okay. Number 2, argument from authority. And it is not actually logically invalid to make an argument from authority. That's not actually true. That's itself a fallacy a lot of people don't know. For example, I come on and I say, drinking from this type of cup, I don't think that it's safe because I think it contains such and such. And you look back and you say, well, I don't think that's true. Prove it. And I bring in my professor, Professor Bob. And Professor Bob comes over and says, I'm a professor at such and such university. I hold 14 PhDs, and I am currently accredited by 12 universities, and I am the foremost authority in the world on these types of cups. And I hereby state, that this type of cup is dangerous because of such and such. That is an appeal to authority, but it's not actually logically invalid because of 2 things it must meet. Number 1, it has to be an expert consensus, meaning not just Bob who says it, but also Bob's peers, the greater community of scientists as a whole, have to generally agree upon it. Just because somebody over here who is a fully accredited scientist who doesn't agree with it says that they don't agree, that doesn't make it invalid. The majority of experts need to agree. Not everybody, but the majority of them do. And that you should not use a appeal to authority as an end-all to your argument, by the way. It should be supporting evidence because unless the consensus is absolute. The second part is you have to have actual experience. Experience doesn't require credentials such as degrees or anything like that, although it's very, very important to have those. You could be somebody who's worked with something for 20 years or something to that effect. So, like for example, take Geiger counters and stuff. I'm not an expert at Geiger counters, but if I keep going like I am, using them and all this stuff for another 5 or 10 years, I might be able to call myself an expert on them, even though I don't have any degrees in the subject because I've used them for so long and know so much about them. Not yet, but maybe in 5, 10 years. Whereas with computers, I can call myself probably an expert in computers because I actually have piles of years of experience, over 20, and I have a degree and everything like that in the subject. So I'm not. So it depends on how you look at it. Now, the fallacy of appeal to authority occurs when you bring somebody on and say, well, here's Bob the scientist, and he says that these things are safe. And then you look it up and you find out that, well, Bob doesn't really, Bob could have a great degree, right? He could be #1 from Harvard, and yet he's got these ideas about this cup here and its safety that don't match any other scientist out there. He's in like fringe science. Because just because you have a really fancy degree doesn't make you any good. Doesn't make you bad, doesn't make you any good. It has a lot to do with who you are and how you actually do it, not just where you went to school. Those are logically invalid arguments when you appeal to authority, but there's no real authority there. That's the actual appeal to authority argument. Next one, number 3. That's 3 out of 10. Modus tollendo ponens, the disjunctive syllogism. You're like, what the hell did you just say? Modus tollendo ponens. Yeah. Okay. So basically, a disjunctive syllogism is when I say A or B is part of my first major premise. I say something like, what's a good one? I'm going to go to McDonald's. Or Burger King. I went to McDonald's. Wait. Today I'm going to McDonald's or Burger King. I went to McDonald's and therefore I didn't go to Burger King. Right? Well, that's not really true because I could have gone to McDonald's and then decided to go to Burger King. I mean, it's loose. It doesn't close up tightly and nicely. So, in fact, in those types of syllogisms, what you should do is break them into two syllogisms. But having that or condition in the middle is what really tosses them out there. I have a good example of one right here. Let's see if I have a good example of a disjunctive syllogism. I can't think of a good example of them, but I might say if I give you a coffee, then you'll have a coffee. Whereas if if I give you a coffee, then I gave you a coffee. If I go and look at you and see that you have a coffee, it does not mean that I gave it to you, but it implies it, but it doesn't mean I did. It's kind of the your way or the highway sort of scenario. It comes up a lot of times. People will put up two criteria and try to steer you on one or the other. It's logical fallacy. Always go for one. And in fact, I should point out that when you prove something, when you try to prove an argument, you prove that it's true, or that it is, or that it's not true. But you don't. It's not true or false. It's true or not true, or false or not false. It is not true or false. That's not the way arguments are done. And so, if your argument is not true, it doesn't make it false. It just means that your particular way of doing it was not true. Just keep that in mind. Next up is shifting the burden of proof. Shifting the burden of proof is when you make a claim, like I'll say, this cup is dangerous. Bad. And then I turn, and then at this point, I've said that this cup is bad, so I have the burden of proof to prove it's bad, right? You know, there's no significant evidence either way. And then I turn around and look at you and say, well, you don't think it's bad? Will you prove to me why it's not bad? You know, the person at McDonald's gives me a cup, and I pick up the cup and say, this cup, the soda in it is bad. And I look at the McDonald's person and say, you work here. You're the one who sold it to me. You tell me why it's not bad. It's your cup. Shifting the burden of proof. Burden of proof's on me. I made the claim. Sorry, too bad. Okay. They do that all the time on YouTube. Next one, begging the question. Begging the question is kind of a circular logic, circular reasoning. For example, I got a good example here. Cyanide should be banned. Okay, that sounds fine. Why? Why should cyanide be banned? Because cyanide is dangerous. Okay, well, why is it dangerous? Because it should be banned. Why should it be banned? Because it's dangerous. When you make a claim, you want to support it with some evidentiary explanation of why. I would say cyanide should be banned. And you say why, and I say, well, because studies have shown that X amount of it, you know, has this effect in a human being. That would be proper. Circular reasoning is no good. When people say something is because, you know, it's circular. It's terrible. I hate that when people do that. Next one, statistical fallacy. Well, radiation could be harmful to people, but there's never, ever been any proof of it being harmful to people below this statistical level. And here's a bunch of statistics I have over here to prove that's true. It's never been shown below this level. Therefore, it's not going to harm you at all. It's completely safe. Okay, that's kind of a statistical fallacy. It may be true. It could be completely true, but the argument is false the way it has been portrayed. Because statistics, when you use statistics to hide things, in that case, it's just because cancers are hard to pin on a particular source when you drop below a particular rate. It doesn't mean they go away, and it doesn't mean the causes of them go away. It just means that it becomes really hard to pin down what did it. Statistical tricks, when people hit you with piles and piles of statistics, and they try to blow you away with those. It doesn't mean their argument's true. It doesn't mean their argument's false. It just means that that's a really poor way to do it, and you can't draw proof from that. That gets into the next one, 7. Hold on, we're almost done. That gets into 7, which is really an extension of 6. Fallacy of complexity. Let's see. Here we go. I say that such and such is true because of this, and this effect, and that effect, and because of this way this works, and blah, 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 blah. Now, you need to tell me whether you agree with that or not. And I'll be like, why? I don't know. Well, if you don't know, You're probably not true. When you try to blow somebody away with complexity, same with the statistics, for example, I say something like, bananas produce radiation. I eat bananas and they're tasty to me. I don't think there's any harm. And you come back and you start hitting me with, look up this, do the research on it yourself. Here's a piece of information. You do the research. Here it is. Here's a link to some statistics you can look at, and here's what Dr. Such and Such said. Blah, 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 and I start hitting you with a bunch of stuff. You're wrong. The radiation in the banana is going to hurt you. It's going to kill you for sure. Here's all these statistics and proofs and everything like this. You keep dumping stuff on them like that, and you haven't made a single real argument. What you've done is just flooded them with stuff, and you're right because they can't come up with an argument against you, because all you have to do is say, well, did you read this proof over here? Well, I didn't get to it. Well, I guess you're just talking out of your whatever then. That's actually a fallacy itself. That's a common one, dumping a bunch of crap on people. You'll find that all of the time, especially the more extreme people get in their beliefs, the more they tend to do that. It's very, very annoying. Hit somebody with a simple argument. I believe this is true based on this and this and this. It's not. You don't have to reduce your argument to some little tiny itty bitty bitty thing. You can have a lot of proof, but you should hit them with the basic important facts, the basic studies. Maybe make links to that stuff, but don't just dump it on them and then tell them they're wrong because they haven't read it. That's just silly. We're on 8 of 10, almost done. Equivocation fallacy. Coffee has been proven good for you. And then here's I can cite this study right here from Harvard where they say blah blah blah, blah it's been good for you. And if you wish, I have 40 other studies I could show you, but that's supplementary. This is the one study I'm showing you from Harvard, shows that coffee is good for you. Now, this alcoholic drink contains coffee, and therefore it has a cumulative good effect because it contains coffee. Equivocation fallacy. I'm equivocating the two together when they may not. Now they may. The coffee in the alcoholic drink may be perfectly good, but you can't just say it is naturally just because they're both coffee. That's an equivocation fallacy. When somebody talks about beta radiation, alpha radiation, or gamma radiation, and tries to add them up and say, well, it's this and this, they're the same. Things like that are not the same. You know, cars and motorcycles, things that are not actually equal, but people try to draw equivalences. And the usual reason people do this is this. They know that they can easily prove that something is true that supports their argument for one type of thing, and so what they'll do is they'll find they have an argument they're trying to prove about some sort of thing. They find something else that's very similar to what they have that they can prove to be correct, and then try to equate the two and say, well, it's true for this one, it's basically the same as this one, so it must be true. Got it? It's false. Watch out for those all the time. People do that stuff constantly. Yes, it's nice that this drink contains coffee and that coffee is good for you, but is this drink good for you? It's not coffee. It has coffee in it, but maybe it's not good for you overall. 9 of 10. 9 of 10. We're almost there. Fallacy of credulity. Well, it's actually it would be the result of not understanding something. An argument of ignorance. Argument of stupidity. Okay. Here's an example. It would be a good example. One of my favorite ones of all. I don't believe that evolution is true. How could this entire world have come from evolution? All of this complexity it just randomly occurred from evolution? Just random and by chance? How is that even? I can't even believe that could be possible. Well, first off, I should point out that as a poor example, evolution has nothing to do with random chance. Which is a huge misconception. But so I guess I shouldn't have used that as an example. But the concept being, I don't understand how it could be, therefore how could it be true? That is called the argument from ignorance, the argument of credulity or incredulity. Okay, it's an argument from incredulity. I like to call it argument from credulity, but that's actually kind of a joke on my part that I think is funny. And if you know what credulity means, you get why that's funny. But basically, we'll call it an argument of ignorance. The argument of ignorance is, I don't understand how that can be true, therefore it's not. So you're saying that a black hole is smaller than a pinprick? It's, itty bitty tiny little thing, and yet it's got the gravity of a star? Come on. That doesn't even make sense. Really? Argument of ignorance. Just because you don't get it doesn't mean it's not true. Because I don't know if you ever noticed, but not understanding things is one of the primary tenets of being human. We are all of us, especially me, very stupid. And we all forget things constantly. We're not stupid. I'm stupid. But the rest of us are not. So basically put, there's so much that we don't know, to be honest. There's just tremendous amounts we don't know. And we can't sit back and say because we don't know and understand something if it's not true. Really? Are you kidding me? Okay. Last but not least, false dilemma. It's related to the modus tollendo ponens argument. It's almost like a poorly formed disjunctive syllogism. Okay. Look. It's either this or it's this. Pick one. Well, either you're correct or you're lying. That is a good example. You're telling me that this coffee cup is this coffee cup's dangerous. Well, either you're gonna prove it's dangerous or you're a liar. Now the problem with that is a false dilemma. If I'm saying this coffee cup is dangerous, I could prove it, and if I can prove it, then it's dangerous, right? Probably is dangerous. But if I can't prove it, it doesn't mean that I'm a liar. I could have just been wrong. In fact, often you're just wrong. I did my math wrong. I figured something else wrong. I could be a liar. But a false dilemma is when you propose fewer possibilities and try to force somebody to go for one of them than there actually exists. This happens all of the time. Example being 9/11. 9/11 conspiracy folks use the false dilemma fallacy all of the time. Well, look. Either this happened over here, which, if you look at it, doesn't make any sense. That's an argument of ignorance and a false dilemma put together, by the way. Or it's this over here. So, like, either an airplane hit it in this perfect way that caused this exact thing to happen, which, are you kidding me? How could that have occurred? Or, obviously, you know, the New World Order blew it up or whatever. Okay, that's a false dilemma argument of ignorance put together. Yeah, so if you look at a lot of conspiracy theories, you'll see a huge number of these fallacies built into them. And by the way, ironically, dare I say this, because you all know how I hate conspiracy theories, but I'll at least say this because I have to try to be truthful here. Even though their conspiracy theories are just chock full of logical fallacies quite often, some of them, by the way, are not. Some of them are very well formed, and the ones that are very well formed often sometimes tend to be true. But a lot of them are just full of, you know, logical fallacies. But even though they are, it doesn't make them false. Wish it did because they annoy me, but it does not actually make them false. They have to be proven true based on their own merits, but you can toss out arguments that have logical fallacies. So there you go. That's almost 40 minutes of me blabbing about what is true and what isn't true. And remember, the theory is the highest form that anything can take in science when it comes to determining how stuff works. Nothing is false. Nothing is provable false. Things are false. Nothing is provably false. Nothing is provably true that exists in the real world. They're just very close to true or very close to false. Watch out for fallacies, but if you see a fallacy, it doesn't make the argument invalid. It does not make the point invalid. It makes the argument itself invalid. But this has been Tom from anti-time.com, and oh my God, this was a long one.